Hello everybody, welcome or welcome back. In the previous video we saw about corrosion control. All of this we saw the main classification, and we also covered protective coating, galvanization and tinning. And let's come to the next point, which is surface conversion coating. So I'll tell you basically what is going to happen in surface conversion coating. So I'll tell you the basic principle first. Suppose if we take an iron, it undergoes oxidation, becomes Fe2O3. This is more prone to corrosion. It can cause more corrosion to the metal. So that only if you take aluminum, it undergoes oxidation, it becomes aluminium oxide. This acts like a protective layer on the surface and it prevents further corrosion. This is basically known as anodizing. Metals which can form oxide coat for protection from corrosion, we can induce or we can forcefully make this metal to go oxidation. That's why induced oxidation I'm telling. This can happen, means oxidation can happen, and when the metal becomes anode, this is called as anodizing. This metal is becoming an anode, right? Because it's undergoing oxidation. So anode and forced oxidation, so induced oxidation I can tell. Develop metal oxide coat on the metal, making induced oxidation. So that way this is happening. This is the main gist of what I'm saying. But not only if we take iron, it's going to become Fe2O3. It cannot protect iron from getting further corrosion. In fact, it's going to make it more corrosive in nature. So that's why instead of coating another metal, we convert the surface in such a way that it prevents corrosion itself. We are not attaching it with another metal. We are not coating it with another metal. We're changing the surface itself. That's why it's called as surface conversion coating or surface conversion. Also is fine, but okay, surface conversion coating we can say. Now I'll explain this to you in a bit more detail. Anodizing of aluminium. I told you in the beginning, anodizing of aluminium and the impressed voltage, these are electrolytic cell, means anode will now become positive. That you have to consciously a little bit remember. So let's learn more detail about anodizing or anodization of aluminium. Here I told you aluminium is going to act like positive, and this is acting as anode only, but it's going to become positive. And this is connected to an inactive metal, like you can say steel, this, and here battery is there, positive, this is negative. So this is reverse in electrolysis. This is electrolytic. It's reverse, right? In electrochemical cell, anode was negative, cathode was positive. Here anode is positive, cathode is negative. So this is an electrolytic bath where this is dipped in. This is going to contain 5 to 10% of chromic acid mixed with H2SO4. Thing is, chromic acid acts as a good oxidizing agent in the presence of H2SO4. And the temperature is 35 degrees Celsius and 40 volts. So under this 35 degrees Celsius, 40 volts, let me just repeat. Here anodization means anode is going to become positive, cathode is going to become negative. Anode is the metal itself and cathode is an inactive metal like stainless steel you can take, and this is dipped in an electrolytic bath of 5 to 10% chromic acid with H2SO4. Chromic acid in the presence of H2SO4 acts as a good oxidizing agent. In 35 degrees Celsius and 40 degree volts, the following reaction will take place. So when electricity and all of that is applied, in anode what is going to happen is that this aluminium is going to react with water. I'm writing I balance the equation. It's going to form Al2O3, or I'll just tell you how to balance it. So why it should be by heart. Aluminium, at least this you can remember, aluminium is going to react with water. That you remember. How and all, don't confuse now. To form Al2O3 plus H plus electron. This much you have to remember. Balancing now we can figure out. 3 is there. So 3. So 6H plus 6 means 6 electrons also will come, and aluminium 2 is there, so 2. So 2Al plus 3H2O will become Al2O3 plus 6 electron. Now in cathode what is going to happen? This you have to remember. Aluminium is going to react with water. It's going to form aluminium Al2O3. It's going to form H2, it's going to form electron. This you have to remember. In cathode what is going to form? The 6H plus plus 6 electron which we got over here is going to become H2 and it's going to raise away. Okay, and overall reaction, now easily you can write H plus and electrons will get cancelled, so 2Al plus 3H2O will become Al2O3 plus H2. Okay, so if you balance, it will become 3H2 actually here also 3H2 because 6H plus is also 3H2 you can write here. Now what we get in this place is we get basically Al2O3. After this reaction, after this process, aluminium acts as a anode positive. There previously also anode only, right? It was whatever is going to get coated is going to get oxidized as the anode only, but here it's going to act as a positive terminal. It's going to get changed, and then in stainless is going to act as cathode. It's going to get dipped in 5-10% chromic acid with H2SO4, and that 35 degrees Celsius 40 volts. The following reaction is going to take place. In anode, aluminum is going to react with water to form Al2O3 H plus electron. H plus electron will form H2. Overall reaction we can write. So that's how we get a coating. Now what happens is, now because of this evaporation or because of this liberation of H2, not evaporation, liberation of H2, what happens in the surface, some tiny holes might be formed, small holes because of liberation of H2. So we have to dip this in very hot water. When we dip this in very hot water, the holes will be sealed, so proper Al2O3 coat is formed. That's it. Simple. So I have summarized it 2-3 times. I hope this is clear. So see you in the next one. Until then, bye bye. So till now, what have we covered? That also I'll just tell once. So corrosion control, protective coating, we have finished. Organic, I told you, paint, greasing or some varnishes, that's done. Inorganic coating, 2 types. One is metal coating and one is surface conversion coating. Metal coating, galvanization, tinning, and surface conversion, anodization. Anodization, here anode is going to be positive, cathode is going to be negative. And similarly when in impressed voltage also. So in the next video we'll see cathodic protection. Until then, see you next one. Bye.